Last part, cloud computing, big data. So we have done a lot of work in grid computing, big data, cloud computing, big data. For example, this is the last year IEEE Congress Big Data in USA. We published a paper. We also published paper, IEEE Transaction Computers and ACM Operating System Review. They are top leading journals in computer science. I got a very simple demonstration here. And the scenario is in Beijing, 10,000 kilometers away. And in UK, we launched local application media player to play some video clips hosted in Beijing machine, 10,000 kilometers away. Let's see what happened. So it may be less pleasant experience, but don't get surprised. Even packet travel at speed of light and it's 10,000 kilometers. You see such a latency interruption. So we provide alternative protocol, communication protocol, CloudJet, and namely it's a European Commission sponsored research project. Same scenario, let's play. So it makes difference, I think, yeah. So we have received very positive comments from independent reviewers like this. Actually, this work has won ACM IEEE Supercomputing Award. This is my team, yeah. We have received quite a few million pounds on the research project from European Commission and the UK government. So at the end, we come back to this timeline with milestone. I think we are now in a better position to understand what happened in the past. We are in a better position to predict what would happen in the future. So let me briefly summarize and computing towards 2025. Concept technology developed within computer science going beyond computer science. Computer science is becoming literacy, yeah, is a fundamental, yeah. So future computers, next decade, so we are forming different knowledge community to tackle the problem that were traditionally solved by individual, but it's not case anymore. We need to form knowledge community. That's why we need a service to encapsulate our resources. We need intelligence, we need connectivity, we need mobility. We want to work anytime, anywhere. We need good interactivity. So if Moore's law continue to hold true, computer would be 32 times more powerful than the current one in 10 years' time. Green computing will be more important. People pay more attention. Computer science will be at the heart of future revolution in business, science, and society. That's all for my talk. Thank you for your attention.
Do we have any questions for Professor Frank? I've got one for you.
Yeah.
Okay, I can see how we in different areas, social media, cybersecurity, and situational awareness, can leverage in most of their areas of research. One is a needle in a haystack. So many a time we are in a situation where we have velocity of data, variety, influx of so many data, but we're looking for information. We're looking for intelligence from those data. So the way we analyze those data speedily, swiftly, and get the right intelligence out of those data would be very easy for some of us in this community. Second aspect is, if we could actually look at the timelines we've moved,
Yeah.
and how computer, I would say the hardware and the design has moved over time, we could actually leverage some of our utility computers into super performance computers.
Yeah,
so
exactly.
By just increasing one or two of their aspects, like the memories
Yeah.
or the disk, we could actually make utility computers super performing computer.
Yeah,
and
yeah.
that could also help us in,
Yeah,
in
yeah.
some of our efficiency
Yeah.
drive.
Yeah. So you're talking about a very important challenge in nowadays computer science, how to efficiently process big data, how to discover useful knowledge from huge amount of data. There is a good example. In the past, if we want to process human's genome information, it took 10 years. But since the invention of two technologies, one is MapReduce, is a very useful algorithm to process, to enable parallel computing. And MapReduce plus Hadoop is a platform for big data. And the processing time has been reduced to 1 day, so 10 years to 1 day. So as Cyril mentioned, the hardware, the advance, and plus the software advanced algorithm, putting them together, such a combination, so it makes big difference, 10 years to 1 day. So today we're in a better position than before to process, to discover knowledge efficiently from huge amount of data. So that's why we encourage data science today. So data science is a newly emerging subject. We are going to launch master program on it with the School of Mathematics. So data science means we got huge amount of data. We use computer science like MapReduce, like Hadoop, to efficiently process large sets of data to discover useful knowledge. So that's today's situation. We should be positive about the future. So we got advanced algorithm, we got advanced hardware platform, we got service, we got interactivity, we got mobility, so more flexible, more collaboratively. So we're in a position to respond positively to the challenges you mentioned. Yeah.
Thank you very much.
Yes.
Hi. So I noticed that all these solutions, they're still relying on machines. By that I mean mechanical, metal parts, plastic. And it looks like we try to mimic nature.
Yeah.
Because it's so perfect because millions of years.
Exactly.
And it's done what we're
Yeah,
trying to do,
yeah.
but it's done
Yeah,
for
yeah.
millions of years. You know, there was a recent article published in Nature Methods where they created a tiny brain to study the neural processes and synapses.
Yeah.
I'm curious as to, you know, I think this is very important, this kind of computer. But what are your thoughts on leapfrogging this and really focusing on maybe bio 3D printing brains, which were, you know, I think our brains require like 20 watts. Right?
Yeah, yeah.
So you know you got the capacitive human brain, the low power consumption.
Yeah, yeah.
And which could quickly be
Yeah.
3D printed eventually.
Yeah, yeah.
You know, it seems like that's future beyond this.
Yeah, yeah,
future.
exactly.
And it seems like what are your
Yeah.
thoughts on that? How to get
So the fundamental change is to get rid of traditional Turing machine. Turing machine, in other words, is a stored program machine. So whatever the tasks are, you have to code the program in advance. It's stupid thing in many scenarios. For example, amoeba respond, adapt to the changing environment, the temperature drop. So of course, you can code program in advance to guide amoeba to respond in that way, but that's stupid. So even 1 + 2, you need to code program. When I was a university student, I saw this stupid. For example, 1 + 2 = 3. You have to code program. A = 1, B = 2, C = A + B. So in this case, maybe 5. But in many cases, in real life, in reality, we don't need a program. We need a natural instinct to respond, like Pavlov's dog, like amoeba's behavior. So that's why we got a lot to learn from nature. Yeah, nature is perfect. It was designed by the God. Yeah, so much better than any machine we made. Yeah, so 70 years, too long. It is time to consider the next generation of computers, next generation successor. So that's why we label our research group Future Computing Research Group. We focus on newly invented things and try to introduce to traditional computer architecture, try to revolutionize, try to save energy, make them green, more efficient. Yeah, that's what we are doing. Yeah.
That's the final one. Does anyone want to have a go? Okay, that's the final one. So, regards to similarity to nature, we had a situation where you have a neighbor and it does relate to historical type information. It does I would say awareness of the environment, and you have that comprehension and prediction, protection, and response.
Not in a programming way, so it's a circuit. It's a straightforward, simple energy saving. Yeah.
What are your thoughts in porting that type of reasoning into cybersecurity? What do you think you could actually leverage?
By nature, cybersecurity needs powerful computers, and so the power of computation may have more secured mechanism. On the other hand, and other technology like quantum computing, quantum communication, by nature they are more secure. Yeah, so they could contribute in many ways. Yeah, so one hand you got superpower. On the other hand, by nature they are secure, and if we learn more from nature, we may get inspired by using new mechanisms for security. Yeah, so get rid of traditional things. Yeah, so at least two ways, and we push him forward. I think. Yeah.
Thank you very much.
Thank you. Yeah.